Last time we had a look at the different data preparation steps. But how to use them? This is the part of this video. We will implement all the specific steps into a Jupyter notebook. How to get data. And there's also a Titanic challenge. 688 values missing from 891 is a lot. Hello and welcome back. I'm Data Science Dom, and today we learn how to code the data preparation steps. So let's jump right into it. So the first step is loading the dataset. If we jump right into it, first we need some important libraries. We need pandas, we need seaborn, and different subcategories of scikit-learn. For example, how to select the model selection, which is a train test split in there. We need preprocessing to scale our dataset and one hot encode it. And we need some column transformers, a pipeline, and a simple computer. I will explain them on the flight. Then we already come to our first step, how to get data. To get the data, we have here our load dataset, where we can use seaborn to load a dataset, and it's the Titanic dataset. If you don't know about the Titanic dataset, open your browser, go to categorical.com, and there's also a Titanic challenge, means we have the competitions, and here's the Titanic machine learning protocol. If you jump right in here, you see all the data, all the explanations, and some simple code which explains everything. We see all the columns explained with their definition, what is the ticket class, what is the age in years, do they have siblings or parents, what is the ticket number, maybe not that important for the classification step, and yeah, the cabin number and everything else, and everything in more detail. But we get the data, in this case from seaborn, so we can have a look at the first few rows. We see all those columns, as explained by Kaggle, are in there. We have to survive, which will later be a label if you want to do a classification, if the person survived or not, and everything else in here. Then we can print the dataset shape. With the f.shape, the f is our pandas data frame, and we have like 891 rows and 15 columns. We can print our missing values by using the data frame, use the isNull function, and summarize everything. This is summarized by column. So we see, oh, a lot of ages are missing and a lot of text are missing. If we go to the overview, we see, oh, in the deck there was already a lot of non-values. 688 values missing from 891 is a lot. And this will be a problem if you want to use this column. But next, first we need to identify which columns are useful. Therefore we have to select useful columns. Surely I manually created all those columns, but in a project later on, you will have a look at the different columns and think of, okay, are they interesting or do they correlate with each other? And based on this, you will exclude or include columns. But in our simple case, we just manually use them. The next step is some good old feature engineering. We can use the siblings and the parents and add +1 to get a whole family size of all the members. So we have the family size of 2, which saying, okay, the person had one sibling, but no parent was on board. So +1, so the person itself plus the sibling. In this case, no siblings, no parents. Okay, we have a family size of 1. Then we need first to extract labels and features, because we want to encode them differently. So this is pretty simple. In the features, we just drop the survived, because the survived will later be our label in the end. Go from axis 1 means we go through the columns itself. If you have a 0, it's looking throughout the rows in the end. If you have the Y, it's just the survived column. So pretty simple, isn't it? You know what else is pretty simple? Subscribe to the channel and like the video. Thank you. Then the next and one of the most important steps is the preprocessing. So the preprocessing. First, we can select all the columns which are either integer values or floating values. So we have a list of columns selected from our features. The same we do with categorical features. Categorical in here means we don't have numerical values which we can see the difference in between. It's only categories. In pandas, it's like objects. Objects usually are strings, but in new versions of pandas, they want strings separately, or they are encoded as Boolean values, true or false, like survived, not survived, or categories in the end. Those are all categorical columns from our features, and we have to do some cleaning because not every column, as I pre-checked it, was already encoded in the right order. So we use all the categorical features of our features at all and cast them as type strings. So we are ensured everything is a string. So even Boolean values are as string true as string false, but doesn't matter, we will handle this. Then we create a pipeline, as I mentioned here, it's a numeric transformer, so it's for all the numerical values later on. In here, we can define steps. The steps is what passes the pipeline. So we go through the first step, then we go through the second step. So the imputer means everything that is not available with values, like in the numeric value we had the h's, we will replace with the median value. So what is the median of all the h values without the non-available values, and those will replace the non-available values. Then we scale. So we use a standard scaler which uses a Z-score standardization. So we take our current value, subtract the mean value and divide it by the standard deviation. So it's not like the min-max normalization which I explained to you in this short. So it's another idea to scale the features. Then we do the same for categorical values. Here we use the most frequent because we can't use a median value of categorical values. Because what is the median, for example, between male and female? That's not possible. So we use the most frequent value. So if there are many more males on the ship than females, we replace the non-values with male, or other way around. Then we encode. Here we use a one-hot encoder, meaning each category's value gets a single encoding. For example, if we have male, let's do this as a comment, this will be replaced by 0, 1, and the female will be the other way around. And you must think of the dimensionality of this list, or this one-hot encoded value is the possibility of amounts of categories. For example, if I have in the same column a child, then everything will be enhanced by 1. So we have a 1 over here, one more dimension over here, and we get the child for the last value, which will be 0, 0, 1. Exactly. And then we use a column transformer, meaning we just map everything to our features. Like we have our num, which means the numeric transformer will be applied to all numeric features, and all categorical transformer steps will be applied to all categorical features. And as easy as that, you already pre-processed all of your data. This is right now everything you need to apply later on, but it's not applied yet. So we first split the data right now, and then we apply it. To split the data, it's pretty simple. We take the train test split function. First we get all our features on the train, then our features on the test split, and then the same with the labels. We pass our features, our labels, and we can either define how big the train size should be or how big the test size. 0.2 meaning I have a test size of 20% and a train size of 80%, which is pretty common. We set the random state, so every time I execute this code again, it will have the same split. And we stratify it by y. So we try to split based on the labels that they are separated commonly. So I have the same label distribution in the testing and in the training set. And now, with our split data set, we can finally apply our preprocessing. To apply them, we simply use our preprocessor, which we defined, which is the whole column transformer over here, and fit transform it on the X train. Meaning fit transform, the fitting, is all the time we see the data from our X train and adjust our preprocessor to those values. Meaning we extract the mean value from there and the standard deviation. And transforming means we then apply the transforming steps to this. It's pretty important that you know it's the fit transform for the training set, because we want the statistics of the training, and later on only transform on the testing set, because then we take the statistics from the training set, because this is where our model will later on learn, and apply them also to the test set, so we don't have later on like a data set leakage or something like this, and have clean values and have the same statistical distribution. Then I just added this code. You don't need it later on. I just wanted to show you how we can reconvert it to a data frame, because after this, it's just an array like a list with values. And I recompiled it as a data frame so you can see the different columns. All the columns are now named as, for example, numerical or categorical, and they are encoded. We see here that none of them is missing. And if the categorical values, we see, okay, we have 0.0, 1.0, minus values or plus values. The minus and plus values are because of the standard scaler. As we don't make a min-max normalization, we have possibilities to positive and negative values and not being between 0 and 1. So thank you for your attention. You now successfully created your first data preparation pipeline. You can now use those data points, create a model, and simply check if the results are better than before data preparation by simply putting xtrain or xtest into the dataset. So thank you so much for your attention, and see you next time when we dig deeper into artificial intelligence.